Assalamu alaikum. This is Miss Linda, your physics tutor. I would like to welcome you all to the physics review lesson. In this video, inshallah, we will review for the final exam. We will have only one unit for the final exam, which is momentum and impulse unit. This unit includes three sections. Section 1, momentum and impulse. Section 2, conservation of momentum. Section 3, elastic and inelastic collisions. We will take a quick review about each section. In section 1, we studied about the linear momentum, it's simple P, and the definition of momentum was mass times velocity. Mass times velocity, it's the unit for mass, which is kilogram, unit for velocity, mass per second. Any moving object, it has a momentum. If the object is not moving, its velocity is zero. It doesn't have a momentum, it's momentum zero. Now, the other concept we've studied in this unit, it was the impulse. The symbol for impulse was I. Now, the definition of impulse actually has two definitions. The first one was force times time, and the other one, change in momentum. Now, if you have a moving car and you try to bring this car to a stop, you're going to slam on the brake to avoid collision. The car will stop eventually over some duration of time. So you apply the force to stop the car. It will take time, this car, to stop. Force times time, this is the impulse. Now, at the beginning, the car was moving. It has a momentum. It has a specific velocity. You bring the car to stop, so its momentum becomes zero. So you have a change in momentum. That's why impulse has two definitions. It's force times time and change in momentum. Since it has two definition, which means it has two units, I can use the same unit of impulse because it's equal change of impulse, change in momentum, which is kilogram times meter per second, or I can use the unit of force, which is Newton, times the unit of time, which is second. Now, the other concept we've studied in this unit was impulse and momentum theorem. Now, impulse and momentum theorem states that when a net force applied on an object over a certain time interval, the force will cause a change in the object momentum. So I use the impulse, since the impulse has two definitions, impulse equal change in momentum and impulse equal force times delta t. So I can say that force times delta t actually equal a change in momentum, and this one we call it impulse and momentum theorem. And actually this is a second form of Newton's second law. So this one I can write it as change in momentum, it's mass times change in velocity. If I have the same mass, I can take the mass as a common factor outside. So it will be m. Change in velocity, it means v final minus v initial. And we solve questions regarding impulse and momentum theorem. I would advise you all to practice on the same questions we did before on the class. Now, in section 2, we've studied about the conservation of momentum. We said momentum is always conserved. And the conservation of momentum state that the momentum before equal momentum after, or initial momentum equal final momentum. Okay? And we studied actually three types of collision in section 3. Three types of collision. I have perfectly inelastic collision, elastic collision, and inelastic collision. Now, what is the difference between all of them? All of these collision, the momentum always conserved, whether it's inelastic, elastic, or in between inelastic, perfectly inelastic, elastic, or inelastic. Momentum always conserved. Now, the difference now in kinetic energy. And we use fit simulation. Let me just open this one. Okay. We said if I have the collision in elastic, I just move this pointer here. Now, before the collision, you look at the momentum here, I have 0.5, and here I have 0. If you add them, it will give you 0.5, so momentum is conserved. Kinetic energy, you see the kinetic energy 0.25. This is before collision. Now, this is inelastic. If I hit the play button, now what happened? Both of them actually, they stick together and they moved as one object. Now look at the kinetic energy. Kinetic energy now 0.06. Now this energy is gone due to the collision, due to the the friction between them. It went as heat maybe, but I have some loss of energy. But the momentum is the same. If you add these numbers, it will give you the same number as before, which is 0.5. This was for inelastic collision. Now, elastic collision, and we've studied cases for inelastic collision, like in real life situation. If you have, for example, you have two trains at the beginning, they move now together as one object with the same velocity. Or you could have this car, the police car was stopping, and the other car hit the police car. Now what happened after the collision? Yeah, they moved as one object. This example of inelastic collision from real life. Now let's go back for the elastic collision now. If I make it elastic, okay, look at the conservation of momentum, 0.5 plus 0 is 0.5, kinetic energy 0.25. Now, if I hit the play button after collision, both of them now, they went separately. They don't stick together. They did not stick together. If I add the momentum, 0.75, and this one goes left, it will be negative 0.25. Still, I have the same momentum, which is 0.5. Kinetic energy doesn't change. So whether elastic or inelastic, momentum is conserved. The only difference in kinetic energy. In elastic collision, perfectly inelastic or inelastic, the momentum, the kinetic energy is not conserved. Now, if I make it in between it's not perfectly elastic. What will happen after if I hit the play button? You see what happened? This one continued moving, and this one actually stopped with a little deformation, a little dent, and I have a loss in kinetic energy. So kinetic energy, again, is not conserved, but the momentum stays the same. And finally, after that, we said how I'm going to solve any questions regarding collision or momentum. We draw a table. Most cases I will have two objects. I have to specify my first object and my second object. What should I write in this table? The mass of the first object with the velocity. This from the given in the problem. And I have to write the mass of the second object with its velocity. I have initial. Initial, it means before collision, final, after collision. And then after that, I do the calculation, which means I have to calculate the momentum, mass times velocity. I have to calculate kinetic energy if the question asks me about the kinetic energy, using the formula have m1 times v1 square, and similarly for the second object in momentum, for the second object, mass times velocity and kinetic energy. This everything we've studied in momentum, and I wish you good luck. Next video, inshallah, I will explain about your task in the final exam, what you're going to do for the final exam.